Hello, can everyone hear me? Hi, sorry for the slight delay. My name is Mor Vered. I'm a lecturer here with the Faculty of IT. My expertise is kind of varied because I come from a very multidisciplinary background. So my undergrad was actually biology and chemistry. I then did my PhD in goal recognition. And then I did a postdoc at Melbourne Uni where I studied explainable AI, and that is now kind of my current research topic. So happy to talk to you a little bit about that. So what's explainable AI? So explainable AI is a very hot topic right now, but it's not new. It's been around since the 70s, but it's getting a resurgence right now because of all the black box machine learning algorithms. So explainable AI basically means that we want to convey some information regarding a certain algorithm's internal reasoning process. So we want to do this for a number of reasons. Okay, we want to understand why we've gotten that certain output. We want to be able to adjust that output if it's mistaken, and we need this to trust the algorithm. And when people are working so closely with AI, as they are doing now, a lot more, then trust is not something that is taken lightly. Okay? How many times have you been presented, I don't know, with a path, even a path suggestion on Google, on Waze, or on Google, what's it called? Google Maps. And you're like, okay, that's not right. It can't be. And then you took another way and you realized there was a huge congestion and you were wrong, but you didn't trust it. So that's where explainable AI comes in. So explainable AI is basically, we want to make the output of the algorithm clear to people. We want to make the internal reasoning process clear so that it'll just generate a better interaction. So by black box, which I'm going to use later on, I'm referring to machine learning and deep learning algorithms. So just a small word about that. So who has heard of neural networks? Okay, quite a lot of you. Okay, so now the really hot phrase in everything AI is deep. Okay, deep learning, deep neural networks. You want to have something cool, you want to get a grant, put deep in it. Okay, but deep is not measured into a level of insight. It's just how many layers of processing goes on in that network. And the problem is we don't know what happens. We know the input that comes in. We know that all sorts of calculations are happening in there. And at the end, we get a classification. And then, we get great percentages when we evaluate it. It's 90% right, yay. But we don't know what to say about that 10% and why it's wrong. So that's why we're using explainable AI. So explainable AI is not yet what I do. Explainable AI was originally for domain experts. Domain experts are those scientists that have actually written those very deep networks. And they want to be able to understand and improve their own network so they can get better results, so they can publish, so they can actually improve the state of the art. So, okay, why is it so important? And I'd like to give 2 examples from the real world. So the first example is called Compass. So Compass is a correctional offender management profiling for alternative sanctions. It's actually a piece of software by the North Point company that is used today in courts in the United States of America. Since 2000, well, it's been used before, but in 2016 there was legislation that told judges that they could actually use this algorithm and allow it to have some kind of impact on their decisions. Now, what does it do? It predicts the likelihood of some kind of prisoner reoffending in case of early parole. It takes all of the information about that prisoner, such as demographic information, which includes where that person lives, the gender. It includes salary. It includes physical status, socioeconomic status, but it also includes the penalty. And it takes all of that information, and based on previous information, which is a big database of all of these cases that have been already classified correctly, it can now predict, will this person have a high likelihood of reoffending or not. This result is then brought to the judge, and the judge can use this result to say, okay, I trust this person will not reoffend, or I do, and let it impact them in some way. Okay, so far so good. I'd like to present a specific case. So a man called Richard Loomis in 2013 was under arrest for driving a vehicle that had been used in a shooting. So he pled not guilty to driving a vehicle without authorization, but he did plead guilty to some minor offense. And the judge took his COMPASS score, which said he had a high likelihood of reoffending, and suggested jail time. Okay, so what's the big problem? The big problem is that Eric Loomis could not put up a defense. Okay, the output of this algorithm is deemed intellectual property of the North Point company. So basically they're saying, we have this algorithm. We're not going to tell you how it works because that's our work, that's our livelihood. You can use it. And what happened later, what transpired, there are a lot of allegations saying that while the algorithm does not take skin color into account, because of the information that it does take, a certain because there was higher likelihood already existing due to different biases in the database, perpetuating that people of color were reoffending. So immediately all of the people who were of different color, they were deemed with a higher likelihood of reoffending. Now, Eric Loomis did not know that because he doesn't have the output of this algorithm saying, what was taken into account. So he can't even put up a defense, right? So again, very, very controversial. Another example. We don't have to go far. Who has heard of Robo Debt? Okay, so Robo Debt is a Centrelink kind of automated debt messaging system, which what it does is it calculates the perceived debt of individuals and then automatically sends them a message saying, this is how much you owe. So it did that for a while. And then what happened was that there was a kind of a glitch in the algorithm. It calculated the date it took the whole year's income into account, and then it divided it into fortnightly basis. It averaged it out, and then it said, okay, well, on this month you didn't pay anything. So a lot of the debt were actually non-existent or much reduced, but people who got this didn't know how it worked. And while it did say this was generated by an automatic system, they had no reason to mistrust it, right? So when someone was presented with a debt, they just sought to seek it off, sought to pay it off as soon as possible. So a lot of people paid a lot of extra money, and there are now some allegations that this money was really in need because the people who had this problem were people who didn't have work consecutively, or elderly, or people with child support, like single parents. So they actually had to pay these inflated debts while it was later given back. In the meantime, they really needed the money. And there are a lot of allegations and problems with that now. So should we stop using AI algorithms? We see these mistakes, they're pretty bad, but I don't think so. So my opinion is no, we can't afford to. Right? The human life expectancy is continually increasing. We have more and more people. We need to take care of them and to maintain quality of life on all kinds of aspects. Okay, we cannot afford not to use AI. We need AI. What we do need is to make it explainable. So imagine if you had gotten a debt letter from this, the Robo Debt, and it said, this is how I calculated it, and this is why you're in debt. Well, people would know, but I didn't work. That's not correct. And they wouldn't pay it off as quickly, right? And, the error would be caught up just like that. Imagine if Eric Loomis was given an explanation as to why he was predicted with such high likelihood of reoffending. And the main feature that has contributed to that would have been his demographic location or skin color. Well, then we know we can't trust that one, right? And people would improve it. So I don't think we should stop using these AI algorithms. I think we need to make them better. So we talked about explainable AI, and now I'd like to introduce my research topic, which is human-centered explainable AI. As I mentioned before, I have a multidisciplinary approach. Oh, wow. Okay. So I come from, kind of social sciences. Human-centered explainable AI says we don't only need to explain, we need to explain in a way that everyday people understand, not only domain experts. And let me give you an example. Consider this example, okay? We have a black box deep learning algorithm that takes your electronic medical records, your demographic information, and some domain expert knowledge, which tells me what are the usual procedures, and predicts the likelihood of someone developing lung cancer. Okay, so a 55-year-old man from Norway, we fed all his information into this black box algorithm, and we got that he had a 98% likelihood of developing lung cancer. Okay, by itself, you can't do anything with that. You don't know if it's wrong. You don't care. So we say, okay, let's put in explainable AI. So the domain expert explanation says this is the leading feature, Norway. That person lives in Norway, and that's why he's more likely of developing lung cancer. Still doesn't make a lot of sense. And not only doesn't it make a lot of sense, it doesn't help us at all, because it doesn't tell me what that person can do to maybe reduce their likelihood of getting lung cancer. So what we need is a human-centered example. The human-centered explanation considers this. Norway is a place with a cold climate. Okay, colder climates lead to higher alcohol consumption. People go out to bars, people tend to drink more. Usually when you're drinking, you're either smoking yourself or in company with people who smoke. And that's a direct correlation of lung cancer. So this explanation coincides with the human reasoning process. And not only that, we now know what we need to do to reduce this output. So when we're looking at human-centered explanations, we need to consider causality, so the chain of events. We need to consider the most impacting factor. And we need to consider the factors that we can then change, which is not the same as just explainable AI, where we're just looking at the leading features. So that was it. Do I have some time for questions? Questions? Yes?
Thanks for that. And I obviously heard the Samuel example, but I hadn't heard the offending example. What jurisdiction is that from? Is that United States, is it?
What? I can't hear you, sorry.
The first example you used about the sentencing.
The compass? Okay, yeah.
Is that from America?
Yes, it's in the US, and they're still incorporating it. So there's been high debate about it. There's lots of allegations, but still North Point, the company, has not disclosed it. So the allegations are just that. And it's still being used. So the case that I presented was at 2013. And at 2016, the courts decided that you can still use it as one of the influencing factors. So it needs to be changed. It needs to be changed in the legislation as well. So that goes into ethical AI. You need to enforce it to be transparent, and you need to enforce explanations. Other questions?
Is there a specific, is this actually a specific course that can be taken here?
So this is my research field. We're now, I think in the Masters of AI, we're working on incorporating an ethics in AI course, which would also cover some of this. But this would be taken along with a kind of honors project or a master's project, because you would need to first learn about deep learning, learn about all the algorithms, and then be able to explain
So
them.
just to add to that, if you wanted to start in the area of AI and in a graduate degree that's available at Monash, do you know where your first starting point would be?
Well, I am not the best person because I have not actually gone to Monash. I was overseas for my undergrad. I know that there are people who will be able to assist you with that.
I can assist.
There.
Yeah, so if you want to do AI at graduate level, we've got a new master's in AI that is starting next year. If you want to do it at undergraduate level, the best place I would suggest to start is to take our data science specialization, because that has a lot of overlaps with AI in terms of machine learning and that kind of stuff.
That's it. Okay. Thank you very much.